So welcome, I'm Peter Kuhn from Unity Technologies.
Hi guys, I'm Christina from Demenco.
Today we're going to talk about more of an advanced topic, extending OpenXR through Unity. First, an overview of OpenXR.
Yes, Alfredo did yesterday a good introduction, so this is more a review what OpenXR is. It is a royalty-free open standard that provides high-performance access to augmented reality and virtual reality platform and device. It provides an API that enables developers to build applications that will work across a wide variety of devices. OpenXR aims to solve the current XR ecosystem fragmentation. It enables applications and engines, including WebXR, to run on any system that exposes the OpenXR API. OpenXR provides cross-platform high-performance access directly into the XR device, runtime across multiple platforms. So the picture shows what the problem is in the current market, which has a lot of fragmentation when you build an application. So you have to target all the devices that you want to have to build a lot of time. The idea is that with OpenXR, you only do it once and run on different platforms.
Yeah, and what this means for Unity is we have a plugin that you can enable that basically you build once with that plugin and potentially run on all the different hardware. But we'll talk a bit more about how that works in a little bit.
So a little bit about me. I'm a senior developer at Demenco, which is a company based in the Netherlands. We are a company that does 3D free displays. So without glasses, we do the 3D displays. So we enable you to see 3D without any wearables. So if you guys have seen the spatial apps from Acer, those are our displays over there.
And Unity, most of you probably already know, but we're a platform for creating and operating interactive real-time 3D content, widely used for game simulations, XR. And we have full OpenXR support via our OpenXR plugin, which we first-party maintain. It basically sits alongside of all of our other XR implementations. So we have native implementations for Oculus and Vive and everybody else. But now we have an OpenXR plugin, and you can use this to target PC VR and Android VR. And it's also extendable via a feature framework, which is built into it, which is what we'll talk about today.
And so what we'll do today? We'll show an advanced use of the Unity feature framework by extending the Unity OpenXR API. We'll define a feature that will intercept a native OpenXR call. The feature extension will intercept the xrLocateViews and xrEndFrame calls for OpenXR, allowing the user to change the video view that comes from the runtime and is rendered by Unity. This is useful for scenarios where the field of view doesn't need to be locked in the VR settings. So as OpenXR is not limited to VR headsets, but also AR, and in my case, the 3D screen, this is a useful case to show what can be done with the Unity extension.
Yeah, and just to kind of add a little bit more reasoning for doing this is that we don't allow the FOV to change in Unity when you're in VR mode, because generally it's you want to use the FOV that comes directly from the device, or else things won't feel right, it won't look right. So this kind of allows you to sidestep that for 3D displays, is what we'll build today. So how we'll do it. So as Christina mentioned, we'll hijack the xrLocateViews call from OpenXR. Here's the manual pages on that. Basically, the xrLocateViews is going to give you two views that gives you view and projection info. So each view contains a field of view, which is we're going to want to modify. And the field of view looks like this. It has a up, down, left, right angles. They're half angles in radians, and we're just going to take the ones coming from the runtime. We're going to change them to something else, and then see that reflected in Unity. So to start, we actually have a sample that we ship with the OpenXR plugin. So this is a view of the Unity package manager here. The OpenXR plugin is, you can view it here and enable it here. The samples on the right-hand side, there's one called the intercept feature. So we're going to import that, and we're going to run it. So running the sample, we're going to go through a couple of steps here just to show you how to run that sample and what it does. So we open the sample scene. So once you import in your project, it ends up in the assets folder there. There's samples, OpenXR plugin, intercept feature, and there's a scene that you can open. We'll enable the OpenXR plugin in this section of project settings called XR Plugin Management. And within there, there's this feature groups section where you can enable individual features. This is the extensibility that I was talking about earlier, where there's kind of core OpenXR implementation within Unity, and then individual features can be added by developers or by runtime vendors to add extra features that weren't part of the core spec of OpenXR. So this could be used to implement extensions or to do anything, like in this case, we're going to change the FOV of the view. So we're going to enable that intercept create session. We're going to run it, and we get this view, hello from C#. So what actually happened here? So that feature intercepted the XR create session in a C++ plugin. This allowed us to run custom code when the XR create session is executed. Within this, at this point in time, we send a message from C# down to the native plugin, and then we send it back upon XR create session execution, and we're just displaying that message on the screen. If it didn't work, it would say something else, so that basically showed us that it worked. So that's the simple sample. We're going to take that and modify it for what we're going to do today. So first step is making sure we can rebuild the plugin. We're just going to do this on Windows for now, so we're going to create a DLL project in Visual Studio. So we're making a native plugin. We're going to bring in the source code and headers that came with the sample, and we're going to get the OpenXR headers, and we're going to strip it down to just what we need. So first step, just Visual Studio, make a DLL project. Pretty straightforward there. We're going to go grab the OpenXR headers from the GitHub. So in Khronos group /OpenXR-SDK, Ryan publishes the headers every time we make a release, so you don't have to build them yourself. So just clone this repo, and the includes directory there is a bunch of OpenXR headers. So we're going to include that into our Visual Studio project. And then there's some Unity headers that we actually ship for native plugins. They're actually with the editor. So inside the editor install and data plugin API, there's a bunch of headers that we're just going to include in our Visual Studio project. So Visual Studio project looks like this. We've got all the OpenXR headers. We've got the one Unity header we needed, and the source code file which came with the sample, which isn't pictured here, but it's there. Here I'm just commenting out some stuff that we don't really need. We're not going to log anything, so I didn't include the trace header. So we just commented that stuff out and just made sure we could build. So we now have a change FOV plugin.dll that we built. Copy this to your project, so drop it anywhere in Unity, and Unity will be able to get it. All right, so that's kind of the native plugin piece. We built basically the sample, but we're going to go change it in a little bit. So there's a C# component to this in Unity. This is kind of the editor interface and the runtime interface, like the way that we actually talk to Unity. We have this concept of an OpenXR feature. This is the extensible piece that you can basically allows you to plug in. So here we're defining just a bunch of information for the editor that makes it show up in this feature group section. So I went and modified all the intercept feature, all the basic the sample names, and name them change FOV at this point. So went and made those changes, and then the next step is there's this OpenXR feature class that the sample implements, and Christine is going to talk a little bit about that.
Yeah, as Peter said, the feature can add public fields for the user configuration at build time. So one important thing to notice is that it must override the OpenXR feature scriptable object class. And this class has a number of methods that your method can override. To intercept the functions that we want from OpenXR, you need to override the OpenXR feature hook at instance process address. It's a huge function. Your feature can subscribe to OpenXR lifecycle events such as on instance create, on system change, or session create. to be notified when OpenXR lifecycle events happen and to get access to those handles. So we don't need to do only what we're doing. You have many options to intercept during the OpenXR lifecycle.
Yeah, so to intercept xrLocateViews and xrEndFrame, on the C# side, in that OpenXR feature class that Christina just described, we're going to override the hook get instance proc address function. So basically what this allows for is returning a different function pointer for get instance proc address. So basically what get instance proc address does in OpenXR is every time whenever we want to call into a function like xrLocateViews, we're going to ask OpenXR for that function. So we're going to say, hey, give me the function pointer for xrLocateViews. This allows us to, instead of talking directly to OpenXR, instead it'll talk to our plugin and say, give us the function for xrLocateViews. So it allows us to basically have our plugin be called before OpenXR is called. So it allows us to hook in that case. So we're going to implement this hook get instance proc address, and we're going to call into our plugin, this changeFOB plugin that we just built, and we'll have a method called intercept xr get instance proc address. So that we're going to call down to that. We're going to pass down this function pointer that OpenXR gives us, and basically insert ourselves into that xr get instance proc address chain. So here's the C++ side of that. So we're going to call this intercept xr get instance proc address on the bottom there. The one from OpenXR is passed in. We're going to cache it, and we're going to return our version of it, which is this. So the very top method there. And basically what this method is doing is whenever OpenXR asks for, or actually Unity is asking for, give me the xrLocateViews call, we're going to say, well, it's not the one from OpenXR, it's ours, and then we'll call the one from OpenXR. So this is pretty standard pattern for doing that. We're just going to return our intercepted xrLocateViews, and we'll call the real one when we're done. So we're doing that for both xrLocateViews and xrEndFrame. Then we just basically built some stub functions here for both of those. So the intercepted xrLocateViews and xrEndFrame, and we're just calling straight through to the real one from OpenXR. So this is where we'll insert our changeFOB code, but for now we're just calling straight through. And
this is here where we actually change the video view, so you can see that it is in half angles for the left, right, top, and bottom, and it is in radians. One thing to note is that we are not taking account the aspect ratio here. This is all equilateral, which we will normally not to do, but this is a tutorial, so keep in mind that when you do it for yourself, it's good to take into account the aspect ratio.
Yep. And we're just doing it for all the views right now, so if there's more than we're expecting to, but we'll just change it for everything. So testing. So without it enabled, I guess one other thing to note here is that I have the Unity mock runtime enabled so that you don't need a headset for this. So that basically just allows you to hit play in the editor and go through all the Unity stereo rendering modes. And it mocks, I believe it mocks a Vive version 1. It's just what we chose a long time ago. And we use this mock HMD for all kinds of internal testing. We do graphics tests with it to make sure that nothing in stereo breaks as the engine evolves. And it's also super useful if you don't have a headset with you. You could just hit play and see stereo. So mock HMD is enabled here. changeFOB is not enabled. And when we hit play, we see a FOB of 109, which is approximately what the original Vive was. So now we will enable our feature, and we see an FOB of 60. So that's what we, in the math there, the FOB that we had was set to 60 in this case. So there we see it working. One other thing to note is within Unity, we actually have this runtime debugger for OpenXR, and you can enable this, and basically do a capture from the device. It could even be a remote device, and it will give you all of the OpenXR calls that are made. So you can see, in this case, we're looking at xrLocateViews, and you can expand into every struct and every variable, and it'll show you exactly what was passed down to the run, or passed back to you, or passed down to the runtime. So in this case, we see that the FOV originally was these particular angles, and then after our code, now it's those ones. So you can see it actually working. Then we have a demo here, which is a bit more advanced. Basically, we allowed this to be completely changeable at runtime, but basically taking that intercept script, the sample, and passing down data from C# down to the plugin saying, hey, this is a new FOV, and then we can actually change it dynamically on the fly when you change, whenever something happens in the editor here. In this case, moving a slider. So I think we have some best practices here. If you're going to do something like this, you're building a native plugin, so you're going to have to build that plugin for all the platforms you intend to target. So Windows, Android, maybe UWP if you want to do HoloLens. Also, there's a lot of power in this that you can intercept any OpenXR function and potentially cause a crash, or maybe others are also intercepting, so you may stomp on other plugins and stuff like that. So again, it's kind of an advanced feature, but used with caution, but can allow you to do implementation of things that wasn't possible before with Unity and OpenXR, and we're kind of not in the way. You can do whatever you want there. And another kind of tip here is that if your native plugin wants to call into other OpenXR functions, for example, like you're implementing an extension or something like that, there's one of the callbacks on the OpenXR feature class will give you an XR get instance proc address that you can use to look up other functions. So that allows you to call into other OpenXR functions that aren't ones that you've defined in your own method. Anything else you want to add there?
No, I think.
Good. So that was pretty quick, but any questions or comments?
Yeah, thanks so much. I don't use Unity myself, but so I learned a lot today. But I was wondering, so you don't need a headset to develop in Unity. Is there any advantage that bringing a headset would bring that?
Yeah, so we have a couple different simulation modes in Unity. One is just like the mock HMD that I was talking about, just basically will simulate stereo rendering. So you can check if like any of your shaders are broken or something like that when you're using single pass rendering. But we also have, within our XR interaction toolkit, we have a simulation mode that allows you to simulate all the different inputs. So you can move around, you can move controllers around, you can do that kind of thing. I think the big advantage that headset gives you is that you can actually feel what it feels like, right? Like without, if you're using a mouse and keyboard to try to move things around otherwise, which feels kind of awkward. But for quick iteration, you don't have to, go back and forth depending on what you're trying to do. But if you did have a headset, you can just hit play in the editor and it shows up there, especially depending on which headset you have. Most of them have some sort of link, like if it's a Quest, you can actually wirelessly link it. HoloLens has like a remoting mode, so you can just see it straight from the editor.
I'm just wondering if this would require for multiple builds to be pushed out of Unity once you've created something like this, if you're putting it to a stereoscopic screen versus a VR headset. Do you have two separate builds at that point?
No, it would be the same. So OpenXR kind of unifies all of that. Like in this case, the OpenXR plugin works on the stereoscopic screen that Christina has, and as long as there's a runtime for it, which they do have, or they're working on, and for headsets as well. So all the data comes through OpenXR, and Unity is basically just in stereo mode, reading that data and doing what it tells it to do. So.
Yeah, that's the beauty of OpenXR. You don't need to target any platform that you want, so you just beat your mouse, and then as long as you have the runtime for that device, it will run.
Any other questions?
Thank you. I apologize for missing the first part of the program today, but one of the things that I do love about OpenXR and being able to provide some code that we can build into our state machines that's easy to then apply to multiple headsets. But one thing I've noticed, and I was wondering if you could answer, is if there's a plan to also allow access to hardware-specific activities. For example, the recentering seems to be iffy. If I'm recentering a headset, it works on some and doesn't work on others, or overriding certain functions that might be system level for a headset. Is there documentation or anything available that I could look into to help me maybe overcome some of those hurdles that are more specific to the hardware?
Yeah, so specifically that recentering question, the working group is actually proposing an extension for that allows for recentering, and there is a workaround in that if you, like basically the stage space within OpenXR is not recenterable because it's meant to be lined up with the real world, but if you use the local space and figure out an offset from that, you can actually allow recentering then. So actually within Unity in our newest release, it may be out now or maybe it's coming out in a few weeks or days, we have a workaround for that so that recentering will work all the time basically. So if you want that, basically the developer can choose. As for like other system level things, part of the design of OpenXR is to try to abstract away some of those things so that you don't need, well, ideally you don't have to hard code to a specific device, right? We want to expose more generic APIs and then have your content be able to adapt to different devices and not be locked to a certain device. So there are gaps in the spec right now, and we're working on those, but if there's anything that's really blocking you or others, we're definitely interested in that feedback.
Yeah.
Cool. All right. I got a question back here about depth, and is that something that OpenXR can support or is planning to support as headsets start to adopt hardware that's capable of 3D scanning and meshing the environment?
So you're talking about depth specifically in terms of not the 3D world, but the real world?
Like the real world, yeah. So if we're doing like mixed reality or AR,
Right.
like in the Vive XR Elite now, they've got a depth sensor. Quest 3 looks like it's got one. Apple maybe, whoever. But generally it feels like the depth sensor is going to become an important piece of XR hardware. And I'm just curious if there's plans or a way to consistently or maybe universally get like mesh information from the real world and or anchor points, and if that's something you guys already have or are thinking about.
You want to take that one?
Go ahead.
Alfredo?
Yeah, hi. I'm Alfredo, the chairman of OpenXR. Yeah, so at our last face-to-face in Osaka, we actually talked about this. It's a whole field of environment understanding is what we're classifying it as. And, it includes things like spatial anchors and understanding what's going on in the world. It's very early stage at the moment, unfortunately, but it is something that we are currently very interested in, especially with Apple coming out. We're kind of trying to rush a few products and features out the door. In terms of exposing what information to expose to the user, because, the runtimes control what can get out. So privacy is obviously a big thing for us. So we want to make sure that we don't, expose things that can be misused by corporations to, screw over the user, pretty much. So, yeah, I think stay tuned. I think in a few more months we might have like a roadmap or a plan for that.
And just to add from the Unity perspective, we have AR Foundation, which we've been developing a bunch of AR style features for a while now. And when there's OpenXR extensions or like first drafts of these things, like we'll be basically inserting those into AR Foundation as the way that the data comes up through. So yeah, we're trying to get ready for it as well, since we know that stuff is coming.
Questions?
So I think that's it.
All right.
Thank you, everybody.
Thank you.